we will proceed to the example 1. The question states that use a green theorem to evaluate the integral c x to the power of 2 y to the power of 2 dx plus open bracket y x to the power of 3 plus y to the power of 2 close bracket dy, where c is shown below. So we go for the first step first. Okay, first let's notice that if we walk along the path in the direction indicated, then our left hand will not be over the enclosed area, and so this path does not have a positive orientation. In this instance, I mean that we can't actually use a green theorem to evaluate the given integral. However, if C has a negative orientation, then negative C will have the positive orientation, and we know how to relate the values of the line integrals over these two curves. Specifically, we know that integral c x to the power of 2 y to the power of 2 dx plus open bracket y x to the power of 3 plus y to the power of 2 close bracket dy equal to negative integral negative c x to the power of 2 y to the power of 2 dx plus x y x to the power of 3 plus y to the power of 2 close bracket dy. So instead of using green theorem to compute the values of the integral in the problem statement, we will use the green theorem to compute the value of the following integral. Integral negative c x to the power of 2 y to the power of 2 dx plus open bracket y x to the power of 3 plus y to the power of 2 close bracket dy. So from this integral we have p equal to x to the power of 2 y to the power of 2 and q equal to y x to the power of 3 and y to the power of 2. So remember that p is multiplied by x and q is multiplied by y. So we proceed to the step 2. Using the green theorem, the line integral from the over negative c becomes integral negative c x to the power of 2 y to the power of 2 dx plus open bracket y x to the power of 3 plus y to the power of 2 close bracket dy equal to integral double integral d 3y x to the power of 2. D is the region enclosed by the curve. So from that equation of the line along the top of the region is given by y equal to 1 over 2x, and the equation of the line along the bottom of the region is given by y equal to negative 2x. Once we have the equation, the region is then very easy to get the limits. There we go. 0 is smaller than x and x smaller than 4, and the negative 2x is smaller than y, and y is smaller than 1 over 2x. So we will proceed to the next slide. Okay, we will proceed to the step 3. So now we'll need to do is evaluate the double integral to get the value of the line integral from negative c. So the equation will be integral negative c x to power of 2 y to power of 2 dx and open bracket y x to power of 3 plus y to power of 2 close bracket dy equal to double integral d y x to power of 2 dA. So d, we know that is the region, so it will be, we need to replace the integral d with the value of regions. So it will be 0 to 4 and negative 2x to 1 over 2x y x to power of 2 dy dx. So we have to do the first integral first. It will become 0 to 4 1 over 2 y to power of 2 x to power of 2, and we need to, because we do the dy first, so we need to replace the the y first. Negative 2x, 1 with negative 2x and 1 over 2x dx. So it will become 0 to 4 negative 115 over 8 and x to power of 4 dx. So next step we have to do is the second integral. So it becomes negative 3x to power of 5 over 8. We need to replace the x with the region 0 and 4. And we get the answer is negative 384. So we proceed to the step 4. Okay, now we can forget that the integral in the step 3 was not the integral we were asked to find the value of. Using the relationship between the value of the integral over c and negative c, we know that the value of the integral we were asked to compute is integral c x to the power of 2 y to the power of 2 dx plus open bracket y x to the power of 3 plus y to the power of 2 close bracket dy equal to negative integral negative c x to the power of 2 y to the power of 2 dx plus open bracket y x to the power of 3 plus y to the power of 2 close bracket dy. It will be 384. So that is the answer. We will proceed to the example 2. Thank you.
Hello, we proceed to example 2. The question is, use Green's theorem to evaluate integral over c y the power of 4 minus 2y dx minus 6x minus 4xy cubed dy where c is shown below. Okay, first, let's notice that if we walk along the path in the direction indicated, then our left hand will be over the enclosed area, and so this path does have the positive orientation, and we can use Green's theorem to evaluate the integral. From the integrals, we have p equals to y the power of 4 minus 2y y cubed 4x y cubed minus 6x. Remember that p is multiplied by x and q is multiplied by y. And don't forget to pay attention to signs. It is easy to get in a hurry and miss a sign in front of one of the terms. We proceed to step 2. Using Green's theorem to the line, integral becomes integral over c y the power of 4 minus 2y dx minus 4x y cubed minus 6x dy equals to double integral over d 4y cubed minus 6 minus 4y cubed minus 2 dA. And we will get minus 4 double integral over d dA. D is the region enclosed by the curve. To the step 3. Okay, we are now pretty much done with this problem. After factoring out the minus 4 from the integral, we can use the following fact to finish the evaluation of the integral. Integral over c y the power of 4 minus 2y dx minus 4xy cubed minus 6x dy equals to minus 4 double integral over d dA. Minus 4 area of d, which is 6 times 4. We will get minus 96. Don't forget the fact that double integral over d dA equals to area of d. This is very useful fact. It doesn't come up often, but when it does, it can reduce the amount of work required to finish out a problem. Of course, this fact is really only useful if D is a region. that we can easily determine the area for in this case D was just a rectangle that we could easily get the width 6 and the height 4 from the graph in the problem statement. Thank you.
Thank you guys for watching.